So let's go ahead and jump into the next one now. This would be the idea that if I had something like 5 over 2 plus 3i, or similarly 5 over 3 minus 2 radical 5. Both of these are in a format that we don't want. We don't want I or a radical on the bottom. And so a lot of times you'll see, what's an equivalent expression to these, which is just asking you to practice that skill. And what we're talking about is the complex conjugate. When you have a binomial denominator that you don't want, you actually take advantage of the idea of differences of squares, which we'll get into deeper at some other point. But that's the reason why this works, to say that when we multiply by the same thing with the opposite sign, it's going to cancel everything that we don't want in the denominator. Because when you have a plus b times a minus b, the outer and inner terms of FOIL cancel out, if that makes sense verbally. So distributing on the top, 10 minus 15i. On the bottom, first times first, outer times outer, inner times inner, last times last, and I squared is -1. These two cancel each other. So you have -9 times -1 is +9. So 4 plus 9 on the bottom, 10 minus 15i over 13. And we've successfully gotten I out of the denominator. Similarly here, we can distribute the top. 6 times 3 is 18. 6 times 2 radical 5 is 12 root 5. And then on the bottom, first times first, outer times outer, inner times inner, last times last. So 2 root 5 times 2 root 5 is 4 times 5. Root 5 times root 5 is 5. These cancel just like we had on the I example. 4 times 5 is 20, so 9 minus 20, -11. 18 plus 2 root 5 over -11, and that would be how you would use the conjugate to solve when you have an unwinded binomial denominator.